Today, I'll show you how to create a beautiful particle rain effect using Rust and U framework. This video is based off Frank's work on how to create advanced effects with JavaScript. I encourage you to go check his channel. If this is your first time using the U framework, please pause this video and go watch my video regarding how to set up U framework. Let's go. Let's open the project with VS Code. And as always, let's import our dependencies. I'm going to enable all the WebSys dependencies up front so that we don't need to toggle back and forth. I'll also import some other libraries we'll need down the line. Let's go to our main file and initialize our Rust app like we always do. This is all boilerplate, folks. You should be super familiar with all of this. Now, our application will have just one element, which is where we are going to put the canvas and animate it. We are going to do something very different this time around. I am going to use a regular U component as opposed to a functional component. So if you use regular U components, these are just Rust structs and they have a lifetime. And the reason why I want to use a regular U component is because I want to take advantage of U's actor system so that I can use that actor system to orchestrate the sequence of events that I need to render my animation. I tried to do this with a functional component, but it was kind of messy. So yeah, let me show you what I'm talking about. To be a component, I think we need to implement the component trait. So let's do that. Again, this is just boilerplate, but this is a method where you get a chance to initialize your component. Then you have update and view. Here we will render our little canvas thing. The ID doesn't really matter because we are going to use a reference to communicate. All right, so I need to add canvas here. So you'll see right off the bat that this is a very different syntax than what we have been working with in the past. Now we have components that have a lifecycle. All right, so this is like the boilerplate. Create gives you the opportunity to initialize your component and like call your constructor. So at the end of the day, you need to call, you need to like initialize everything here. Ref default. We need to define what message is. I mentioned that you get an actor system with struct components. So you need to define the messages that you're going to be sending back and forth. So type message, you need to define your own enum with messages. So right now we don't have any messages. I'm just going to create an empty enum. Pop enum MSG and just pass these here. Well, I need to pass canvas. Oh, Jesus. This constructor goes here. Right. In this case, our component doesn't have props, so properties is going to be set to void. Is this void? I'm not sure is that how you call it in Rust, but for all intents and purposes, is void. Right here. Okay, so let's see if this loads. This is like our boilerplate. So this renders an empty page, no errors, looks good to me. Let's move on. One of the cool things of using struct components is that you get to control when the component gets updated or refreshed. And updating the whole component is expensive. So this is your opportunity. This is your opportunity to tune the performance of your application. In our case, there are a few logical steps that we are going to need for our animation. First, to fetch the image that we want to animate. Then we need to configure the animation. After this, we want to continuously call re-render. We want to call render every few milliseconds. There's a convenience method that Chrome offers that will allow us to queue up or request those animation frames as often as possible. I think you get like 60 frames per second on Chrome on desktop. Hopefully one day we get like 120 or something, so it looks like better. So let's just go for it. We need to add these new messages to our enums. So fetch OK. And we will handle these events here. Here we're saying if we succeed to load the image, go ahead and call me with the image data. Where are you going to call me? Here. So we just need to match on the event. So match message. Cool. So if successful, we want to configure the animation right here. Else, maybe we can print an error or something. Probably it's not going to find the macro I'm thinking about. We talked about setting up our animation. So first thing we need to do, so we need to set up animation. To do this, first we need to configure the canvas. All right, we're going to initialize our particles. Let me show you how to initialize like a very big array in Rust. A vector, I will say, not array. So you have a range, and then you can map it to the type that we need. So in this case, is particles. And after we initialize our particles, we are going to tell this component to go ahead and start rendering. We need to add this new message. Add it to the match statement. I want you to see something really cool. How cool is that, guys? Rust notices that the match is not exhaustive. I know this is not exclusive to Rust, but still neat. Let's define a particle. Remember that you can use I think it's the new, yeah, you can just create the new trade, and then that will be like the constructor, the default constructor. These are particles that will like flow from the top of the screen to the bottom. So obviously the initial Y position is 0, and the initial X position will be like a point between 0 and the width of the page. So then what else do we want? All right, so we initialize the coordinates. Then the particles will like flow from top to bottom, so they'll have a velocity, constant velocity, at least at the beginning. So constant velocity, Randy, Jan, range. We'll tweak this, but let's start with like from velocity from 0.5 to like 10 or something. And a size. That's very important. The size of the particle. Bare minimum we need a 1, so that's why we are saying bare minimum we need the particle size to be 1 pixel, and then anything in between 0 and 1. We never implemented the fetch command. All right, so the goal of fetch image is, given the file path that you pass to it, it should get you a JavaScript image bitmap, I think it's called. Yes, image bitmap. And why do we want that type in particular? Because this type can be rendered to the canvas. Yeah, I'm very creative with my error names. So number 1, create request. Finally, at this point, we can create the image. All right, great. So why am I using this type? Some error, because I just want a generic way to package the error and just send it to the caller. Let's see. So we initialize our particles. We didn't really do anything with our particles, so that's not great. Probably we want to store these particles somewhere so that then we can animate them. Yeah, for sure. So what I'm going to do is I'll make the particles part. Yeah. I'll store the particles in the animation. How you call this? Animation canvas. All right, cool. So whenever we want to render, we'll just call the render method. Here is where we'll conduct the location update for all the particles. And to do that, we need to get a reference to the canvas first and foremost. All right, so we got a reference to the canvas. Now, what are we going to do with this? Let's go ahead and like start with like a black background. So context. Then we'll iterate through the particles and just render them. All right, so let's implement these methods on our particles. Yeah, so these renders a small circle with a radius of size, and I'm not sure how to call pi, math.pi. I don't know. Let me look it up real quick. All right, looks like there's a constant that I can use just out of the box. All right, yeah, they should do it. And I always forget to pass self to the functions. All right, so now let's compute the location, the positions. Delta y will tell us where the new wave position is going to be. So then, so this will push the circle to the bottom or further down the screen. When it gets to the very bottom, we want to start from the top again. So all right, I need to declare this as mutable because I'm going to be modifying the contents of the object. So same with this. All right, so we have a little render method here, but it only renders once. So we need like something to constantly call it. All right, so here we can say window wrap, of course, request animation frame. And here you need to pass a callback. The only problem is we need to store the callback in the object that we are working in our component, because if we just say something like, yeah, just call something here, and we just say, okay, unwrap and be done with it. The problem is this callback is not retained by the window. Like the window does not take ownership of the callback, because I guess the ownership rules are different with JavaScript than with Rust, obviously. So what we need to do is we need to store the callback in our all right, cool. So now we saved it. Now let's use it. All right. It's happy enough. Let's give it a shot, see what happens. All right, so we want to make it so that the velocity of the particles is proportional to the brightness of the pixel, of the particular pixel that the particle is on at the moment. So yeah, let's see how that will look like. Let's take a look. Also, another thing I don't like is this looks like snow. It doesn't look like that rain effect that we want. I want to really show that rain falling, because right now we just show like particles, and like on each re-render, like you cannot see the trace, like the path that that drop of water is taking. And I think that's because we are on each render, we are like starting fresh. Like this says, just start with a black background. Instead, what we want to do is we want a semi transparent background so that we can see the older renders. Let's see. Fantastic. So now we can see that all the renders are stacked on top of each other, just with a different transparency. And that gives you the effect of rain. We are not showing the image at all. And to show the image through, what we'll do is we'll reduce the velocity of the water drops when you are in a point in the image with like higher luminescence or brightness. All right, so we need to store the relative brightness map somewhere. So probably we want to do that after fetching the image. So that happens here. So after fetch, okay. Here we have access to the image, and we can just compute the relative brightness and then store it. Then we need to insert rows into the columns. All right, let's implement this function. This is a textbook transformation to transform RGB to grayscale, basically. Yes, we need the bytes. Right now we have an image, right? An image bitmap, but we don't have the data yet. So to get the data, we need to like draw the image to the canvas. Nice. So now we can grab the bytes. Nice. We got the image. Now we just need to remove we need to clear it. Right. Jesus. Okay, I'm using the same name than here. Let me just call it something else. All right, forgot to wrap this. Now let's run it. Well, okay, we have the brightness map. Now let's do something useful with it. So we have the brightness map, then we go to the render method, and then we need to do something useful with that brightness map. So here, when we update the position, we want to pass the brightness map. All right, obviously there's something wrong, but I'm struggling to see it. Okay. I declared the type incorrectly. This is F64. All right. Okay, so we computed this, but then we don't do anything with it. Yep. So row, push, brightness. Then we use it in the render method. Then we need to do something useful to it. Let's see how this looks like. Yeah, so that didn't work. Index out of bounds. I think I know what it is. So I use the coordinates. I use the indexes backwards. I have first we need to access the y-axis and then x. All right, so we get something there. It's not extremely well defined. Particles move extremely low in dark areas and extremely slow in actually areas with higher brightness. So you can see that looks like Keanu has like a skiing problem. So that's not great. Like here on the forehead. So let's, we need to make particles move faster. And also there's not enough definition in dark areas. So I know how to fix the dark areas. Let's just do it. And let's see. So when we render the particles here, we can set the global alpha. Set global alpha to be a fraction of the particle speed. So a higher velocity, higher alpha. All right. Lower velocity, lower alpha, so we won't be able to see through the darker areas. All right, cool. It's looking better. Still freaking me out, like the particles that get stuck on his forehead. But now you can see an image, which is great. So let's get particles to move a little bit faster there. That's here. So we'll just let's just use like a 2 or something. Let's see what happens. Ah, there you go. Now things are moving a lot more smoothly. Yes. And you know what? Let me reduce the number of particles overall so that it looks more pixelated, sort of speak. Let's see. So we go to particles. Aha. Let's do 7,000. All right, let's try something else. All right, it's pretty neat. So we got Mega Man over here. Ooh, how neat is that? You can tell that this image is much higher resolution. Nice. Let's try a third picture. Ah, nice. I bet you that we can tweak the effect for every single picture. All right. Color brings a new dimension to the image and really makes everything pop and look better. So let's store the color. So basically what we're going to do is, instead of rendering the particles using white color, we will render them using the RGB value of that pixel on the original image. So to do that, first thing we need to do is to store the colors. So here we were storing only the brightness. Let's also store the color map. Same type. As a matter of fact, technically we could store it in the brightness map. We just need to store multiple elements to the brightness map. So instead of storing just brightness, we'll store a tuple: red, green, blue. We'll store all these things into the tuple. That way we don't need to keep more state around. But probably we need to change the type of the tuple here. U8, U8, U8. That's right. Okay, and then we'll pass the map here as well. So this will change to U8. Here's the big change. when we render the row, we'll pass this map to. And here we'll say JS RGB. Then we'll pass this here. All right, let's see if it does the thing. Yes. Yes. Yeah, so this is a lot more interesting to look at. And then the colors are like too opaque. Let's change that. So that's our little function here. Let's increase this to 50%. Aha. Yes, look at those particles. This is a lot more interesting to look at. Yes. Neat. All right, let me know what you think, but I don't know. If anything, this is interesting. Thank you so much for watching. Bye.